During a medieval siege, running out of water meant certain death, but the greatest castles had something our modern homes don't: complete water independence. They captured every drop of rain, found hidden springs with simple tools, and stored enough water to survive for months. While we panic when the tap runs dry, medieval people mastered 8 ingenious water systems that worked without electricity, pumps, or complex technology. Today, you'll discover their rainwater harvesting secrets, learn forgotten techniques for finding water anywhere, and see why these ancient methods still outperform modern solutions. Time to build your own water fortress. When you picture a castle, you think of stone walls, towers, and moats. But maybe the most important feature was the one you couldn't see: the cistern. Now wells were common and often the first choice, but they were vulnerable. They could run dry or, even worse, get poisoned by an enemy. So, medieval engineers got clever. They designed systems to rely on a source no army could ever cut off: the rain. They channeled water from every rooftop and courtyard into massive underground reservoirs. These weren't just pits in the ground. They were carefully built, waterproof tanks, and some even had built-in filtration that used layers of sand and gravel to clean the water before it was stored. This stored rainwater could be the difference between holding out and surrendering. The beauty of this idea is its simplicity and how well it works, and those principles are just as relevant today as they were 1,000 years ago. We've become pretty disconnected from where our resources come from, especially our water. This project is a really cool way to change that. Planning your modern homestead fortress. Alright, let's translate that medieval blueprint for your own property. A little bit of planning is what separates a great project from a frustrating pile of parts. You've got to think like a castle architect. Consider your land, your materials, and what you need. First up, site selection. The key is your catchment surface, which for us is going to be a roof. Ideally, you want a roof made of something non-toxic like metal, slate, or clay tiles. You can collect water from an asphalt shingle roof, but just know that water is best for non-potable uses like watering the garden, since it can sometimes leach chemicals. For this build, we'll be focused on a system for garden and emergency use. Next, figure out where you'll put your cistern or storage tank. Just like in the old days, the best spot is stable, shaded, and close to where you'll actually use the water. If you can, burying your tank even a foot or two helps keep the water temperature stable and cool, just like those underground stone cisterns did. This slows down any potential algae or bacteria growth. Now let's talk materials. We're mixing old-school methods with new, easy-to-find materials. Here's your shopping list. For the collection system, standard gutters and a downspout. If you've already got these, you're ahead of the game. A downspout diverter. This is a key modern piece that acts as a first flush system. More on that in a bit. For the medieval filter, a food-grade barrel or another large, sturdy container. A 30 to 55-gallon barrel is a great size. A spigot or faucet for the bottom of the filter barrel. Coarse gravel, about the size of large marbles. Fine gravel, often called pea gravel. Coarse sand. A small piece of window screen or permeable fabric. For the cistern storage tank, a large, food-grade storage tank. These are usually polyethylene plastic and come in all sizes, from 50 gallons to thousands. For a serious home system, a tank around 250 gallons is a fantastic starting point. Make sure it's opaque to block sunlight. A mix of PVC fittings, pipes, and sealant to connect it all. You'll probably need some elbows, adapters, and a couple of shut-off valves. Gathering these materials is your first quest. Think of it as sourcing the stone and timber for your fortress walls. Once you have everything, you're ready to start building. The build step by step. Step 1. The gutter and downspout connection. Our collection starts at the roof. First, make sure your gutters are clean. The first bit of modern magic is the downspout diverter. This device installs right into your existing downspout. Here's how it works. It lets the first few gallons of rainfall, the stuff that washes all the dust, bird droppings, and pollen off your roof, flow down the original spout. Once a little chamber inside fills up, a mechanism flips and sends all the cleaner rain that follows out through a hose, which will lead to our filter. This is our modern automated take on the medieval settling basin. It's a simple, brilliant device that seriously improves the quality of the water you collect. Installation is usually pretty easy. You'll cut a section out of your downspout, fit the diverter in, and seal it up. Step 2. Building the medieval filter. This is where we really bring a piece of history into our backyard. Grab your food-grade barrel. Near the bottom, carefully drill a hole and install the spigot, making sure you get a watertight seal using the included gaskets and maybe some silicone sealant. This spigot is where our filtered water will come out. Now, let's build the layers, an art that's been around for centuries. First, put your piece of window screen over the inside of the spigot hole. This just stops your filter materials from washing out. Now start layering from the bottom up, a 4-6-inch layer of coarse gravel. This creates a space for filtered water to collect and keeps the finer layers from clogging the exit. Next, a 4-6-inch layer of fine gravel, pea gravel. This layer starts filtering out smaller bits of debris. On top of that, a thick 8-10-inch layer of coarse sand. The sand is the real workhorse of our filter, grabbing all that fine sediment and other particulates. Finally, add one more thin layer of pea gravel on the very top. This layer acts as a splash guard, so the incoming water doesn't blast a hole in your sand. And just like that, your medieval-style filter is done. It might look simple, but those graded layers working with gravity are a seriously powerful cleaning technique. We have prepared a file with these units in centimeters and international standards that you can find in the first fixed comment. Step 3. Preparing and placing the cistern. Time for our main storage. Pick a spot for your large tank. It's a good idea to build a level, stable base for it using gravel or concrete pavers. This makes sure the massive weight of the water is spread out evenly. And like we talked about, if you can dig down a bit so the tank sits partially below ground, you'll get that thermal stability that made ancient cisterns so great. You'll need 2 holes in the top of the tank. One is the inlet for the filtered water. The other is for the overflow pipe. The inlet should be positioned to easily connect to your filter's spigot. The overflow needs to be right near the top of the tank. Step 4. Connecting the system. Let's hook it all together. Put your filter barrel up on a stand or some cinder blocks so that its spigot is higher than the inlet on your main cistern. Gravity is our pump here. Run a pipe or a heavy-duty hose from the downspout diverter to the top of your filter barrel, letting it rest on that top layer of gravel. Next, run a pipe from the spigot at the bottom of your filter to the inlet hole at the top of your cistern. Use PVC pipes and fittings to get a secure, long-lasting connection and make sure everything is sealed up tight. Finally, install the overflow. This is a critical safety feature. Attach a pipe to the overflow hole and run it away from your house's foundation, maybe into a garden bed or a drainage area. When the tank gets full, this stops water from backing up or spilling over and causing a washout. Step 5. Accessing your water. The last step is getting the water out. A castle well had a bucket, will install a spigot. The easiest way is to install one near the bottom of the main storage tank. If you put your tank up on a sturdy platform of concrete blocks, it's easy to fit a watering can or a bucket right underneath. For a fancier setup, you could hook up a small, non-submersible pump to push the water through a hose. Now, stand back and check out what you've built. From the roof to the diverter, through the filter, into the cistern, and out the spigot, you've created a complete, self-sustaining water system based on centuries of proven engineering. The first harvest and showcasing the result. There's a special kind of satisfaction you get from watching a system you built with your own hands actually work. The first rain after you finish is a truly rewarding moment. You'll see the water come sheeting off the roof, watch the first flush diverter do its thing, and then see a steady stream start to trickle into your filter. If you lift the lid of the filter barrel, you can see the water pooling on top, slowly seeping down through the layers of sand and gravel. And then the magic moment, opening the filter spigot and seeing a clear, clean stream of water emerge, ready to fill your cistern. It's a visible transformation. The runoff that used to be just a muddy puddle is now a valuable stored resource. After a few good rains, your cistern will start to fill up. That 250-gallon tank now holds over 2,000 pounds of water, a serious resource for your garden, for washing tools, or as a critical backup in an emergency. When the summer sun is beating down and the ground is cracking, you can walk over to your cistern, turn the spigot, and fill a watering can with cool, clear rainwater. You're no longer completely dependent on the municipal tap. You're using a resource that literally falls out of the sky for free. This system does more than just water your plants. It changes your relationship with your environment. You start paying more attention to the weather, and you really start to appreciate a good rain. You're taking a step, however small, toward the kind of resilience that wasn't a hobby for our ancestors, but just a fact of life. You haven't just built a project, you've built a water fortress. Maintaining your water fortress. A castle needed constant upkeep, and our rainwater system is no different. A little maintenance makes sure your system works great and your water stays clean for years to come. The good news is, it's pretty simple stuff. First, think of your gutters as the front line. They need to be checked and cleaned at least twice a year, usually in the spring and fall. A bunch of leaves can clog the whole system and dump gunk into your water. Popping on some simple mesh guards over your gutters can make this chore way easier. Second, the filter itself needs a little love. Over time, that top layer of sand will get clogged with all the fine sediment it's been pulling out. Once a year, or whenever you notice the water flowing a lot slower, it's time for a quick service. Just scoop off the top inch or two of sand, that's where most of the gunk is, and replace it with fresh, clean sand. Every few years, you might want to replace all the filter media, but for the most part, just cleaning off that top layer is all it takes. Finally, take a look at the cistern itself. Keep the lid on tight to keep debris and sunlight out. Once every year or two, it's a good idea to drain the tank and give it a quick inspection. A little bit of fine sediment might make it through the filter over time, but it's easy to rinse out, making sure your storage tank stays clean. By just following these simple steps, clear gutters, fresh filter, clean tank, your system will keep you supplied with water for a very, very long time. So there you have it. A fully functional rainwater harvesting system built on principles that have been proven for 1,000 years. We started with the problem of a medieval siege and ended with a practical solution for the modern home. By blending old-school knowledge with modern materials, we've created something sustainable, resilient, and honestly deeply satisfying to build and use. You've taken one of life's most essential resources and brought the source right into your own backyard. This project is about more than just the end result. It's about learning, building, and becoming a little more self-reliant. It's a connection to the ingenuity of the past and a solid step toward a more sustainable future. If you found this mix of history and hands-on building useful, and you believe in building a more resilient life, go ahead and hit that subscribe button and the bell icon. You won't want to miss what we're building next. We have a lot more forgotten technology to bring back. And I want to hear from you. Drop a comment below and let me know if you've ever tried a project like this. What worked? What didn't? Or tell me what piece of medieval tech we should try to tackle next. Thanks for joining me on this one. Now, go build something timeless. You just witnessed how medieval castles achieved water independence with a single brilliant rainwater system. But here's what made medieval communities truly unstoppable. They didn't rely on just one water source. They mastered multiple techniques, creating a complete water security network that never failed. What if your well ran dry? What if the rain stopped? Medieval people had backup plans for their backup plans. From dowsing rods that danced over hidden springs to fog nets that captured water from thin air, they developed 7 additional water-finding techniques that turned any landscape into a reliable water source. Let's discover the forgotten methods that kept entire civilizations hydrated when drought threatened to turn fields into dust. Imagine your village's well has run dry under a merciless sun, and every sip could mean the difference between life and death. In this video, you'll uncover 7 ingenious medieval water-finding tricks that kept entire communities alive when drought threatened to turn fields into dust. From wands that dance over hidden springs to sacred monastic maps and gravity-fed wooden pipelines, these long-forgotten methods still hold practical lessons for today's off-grid homesteads and emergency preparedness. Let's journey beneath stone and straw to reclaim the secrets our ancestors relied on and never go thirsty again. Dowsing, hazel rod. Imagine standing at the edge of a parched field clutching a simple Y-shaped hazel rod. As you walk, the two branches of the rod begin to cross or twist in your hands, as if pulled by an unseen force, signaling water flowing somewhere below the surface. This was the essence of medieval dowsing, a practice so widespread that manuals from the 12th century document clergy and peasants alike relying on the water witch's tool to locate hidden springs. Contrary to the skeptics who dismiss dowsing as pure superstition, modern blind trials show a hit rate significantly above random chance, especially in rural areas where geological signs are subtle. Geophysicists theorize that the dowser's subconscious reacts to tiny muscle movements or environmental cues, variations in soil moisture, vegetation density, or even changes in magnetic fields, though the exact mechanism remains elusive. In effect, the hazel rod becomes a low-tech geophone and biofeedback instrument rolled into one. Medieval communities valued dowsing for its low cost and portability. When sourcing water for new homesteads or wells, hiring excavators to drill at random could ruin a family's meager resources. Instead, a local dowser would walk the land for a day, marking promising spots. After a successful test well, often just a narrow borehole, the village invested in lining and capping a more substantial shaft. Today, small farms and off-grid homesteads resurrect dowsing as a cost-effective preliminary survey tool. A dowser's walk can cut drilling expenses by focusing heavy equipment on high-probability locations. Workshops and YouTube channels dedicated to modern dowsing draw parallels to medieval practices, teaching enthusiasts how to read subtle environmental signs alongside rod responses. Still, integrity mattered. Medieval dowsers often performed under oaths, pooling community risk, so a false lead could cost more than wasted time. It could doom an entire harvest season. Villagers combined rod readings with surface indicators, moss clusters, animal trails, and even the direction of blade grass growth, creating a hybrid method both mystical and empirical. As we rediscover these ancestral skills, we find that the hazel rod's simple dance across the parched earth isn't merely folklore. It's a testament to human ingenuity, blending observation, intuition, and a touch of magic. Sacred springs mapped by the church. Imagine the hush of a candlelit cloister, the soft scrape of quill on vellum as a monk traces the contours of chapel walls, and secretly records the trickle of water just beyond the stone. In medieval monasteries, holy men weren't only guardians of faith, they were hydrologists in hooded robes. By mapping perennial springs that fed their cloister gardens and infirmaries, monks compiled secret cartographies of life-giving water. To the layperson, these wells were miraculous, but in practice, they sat atop shallow aquifers and fractured limestone. Monastic communities maintained these spring sites with reverence. Annual rituals, processions of robed brothers and chanting villagers, reinforced communal respect for the wellhead. These ceremonies doubled as practical inspections, repair leaks, clear sedge, and deepen the channel. Over centuries, this living archive of spring locations became encoded in manuscript margins and chapel frescoes, visible only to those literate in the monastery's esoteric glyphs and symbols. Archaeological digs at Cistercian abbeys reveal stone troughs carved into bedrock, often sited just beyond the cloister garth. These basins collected water via hidden gutters, channeling it into lead-lined cisterns for brewing, cooking, and healing maladies. Chroniclers like William of Malmesbury noted that certain springs never fail, even in drought, thanks to the monks' careful maintenance, and to a keen understanding of local geology passed down through generations. In practice, secular villagers often petitioned their abbey for access. Monastic lords granted privileges, market days held by the spring, tithes in exchange for water rights, and guidance on constructing their own village feeder channels. Through this symbiosis, the church became both spiritual and hydrological authority. Today, researchers reconstruct these medieval water maps using LiDAR and ground-penetrating radar, confirming that many holy springs align with karst aquifer fractures. Off-grid communities and eco-villages are now digitizing these ancient routes, blending medieval precision with modern GIS to revive gravity-fed springs without electric pumps. By understanding how monks translated geology into theology, we've covered a twofold lesson. Reverence ensures maintenance, and disciplined observation unlocks resources hidden in plain sight. In a world scrambling for sustainable water, the church's medieval spring mapping offers a blueprint, equal parts faith, science, and communal stewardship. Conical well with lime mortar lining. Villagers began the process by digging a wide mouth, then gradually tapering the diameter, creating a funnel that channeled water inward and allowed loose soil to fall away rather than clog the interior. Once the desired depth reached the water table, builders set stones around the shaft's perimeter, each layer slightly smaller than the one above, creating that distinctive conical profile. To secure these stones and seal the gaps, they applied lime mortar, a mixture of quicklime, sand, and water. This stone-kissed lining prevented silt from seeping in and sealed cracks that could introduce contaminants, ensuring the water remained clear and fresh. The choice of lime wasn't arbitrary. Quicklime's alkaline properties neutralized acidic elements in the soil and inhibited bacterial growth, an early form of water purification. In regions with abundant limestone, such as the Chiltern Hills or parts of Normandy, sourcing lime was straightforward. Kilns roasted oyster shells or chalk to create quicklime, which villagers then slaked with water to form a workable mortar. As seasons turned harsh and drought-gripped fields, conical wells minimized surface exposure. The tapered opening reduced direct sunlight and wind over the water, drastically curbing evaporation. Maintenance routines included periodically reapplying fresh lime mortar and scraping away mineral buildup, a task often assigned during communal labor days governed by local custom or church decree. Modern artesian setups echo these principles. Rural homesteaders install tapered casings and use cement grouts formulated with eco-friendly lime blends, balancing structural integrity with permeability. By revisiting medieval conical wells, today's off-grid builders gain insights into passive purification and sustainable construction, simple methods born from necessity, refined over centuries beneath sun-scorched skies. Thatch roof rain catchment systems. Picture a cluster of tightly woven straw roofs, their steep angles slicing raindrops into neat rivulets that race toward wooden gutters. In medieval villages, builders thatched homes not only for insulation but also as primitive rainwater harvesters. The secret lay in the interlocking reeds or straw. Naturally water-resistant and abundant, they funneled precipitation with surprising efficiency. Villagers constructed open-ended wooden channels, often hollowed logs or planks, along the eaves. During storms, water cascading off the thatch gathered in these gutters before pouring into barrels, cisterns, or even shallow wells. Calculating the catchment area was intuitive. A roof spanning 10 meters by 6 meters could yield over 60 liters per square meter of rain, enough to supply drinking water, livestock troughs, or irrigation during dry spells. Maintenance was straightforward but essential. Every spring, local families replaced worn straw sections and cleared gutters of debris, leaves, twigs, and bird nests to ensure unimpeded flow. Thatched roofs, when properly maintained, lasted up to 20 years, making them a cost-effective dual-purpose investment. Today's off-grid enthusiasts adapt the medieval model with modern materials, corrugated metal, PVC gutters, and first flush diverters. But the principle remains the same. Maximize surface area, minimize loss. Ground spouts and timber pipes. Imagine hollowed logs laid end to end, forming a buried ribbon of wood that guides groundwater from a hidden source straight into the heart of the village. Known across medieval Europe, these ground spouts and timber pipe systems were a straightforward, yet ingenious way to tap shallow aquifers without the need for complex excavations or lifting mechanisms. Villagers would identify a reliable water table line, often near springs or riverbanks, and dig a shallow trench along that contour. Into this trench, they placed logs of alder, oak, or pine, carefully hollowed out with chisels and adzes. Each log section featured tapered ends for snug, watertight fits, and joints were sealed with moss, animal hair, or tar to prevent leaks. The entire assembly sloped gently downward, using gravity to maintain a continuous flow toward communal cisterns or well shafts. Because wood naturally resists rot when constantly submerged, these buried pipelines could last decades with minimal upkeep. Maintenance involved occasional inspections at accessible air shafts, short vertical shafts capped with wooden lids, where villagers checked for blockages or damaged sections. If a log rotted or split, a replacement segment could be crafted from fresh timber and slid into place without disrupting the entire system. Historical records from 13th century England describe manor estates boasting water conduits carved from elm that supplied both kitchens and vineyards. In France, pilgrims on the Route de Santiago noted villages with covered wooden channels feeding stone troughs engraved with the village's coat of arms, proud symbols of self-sufficiency. Monastic infirmaries in Germany employed similar timber piping to transport spring water to herb gardens and patient wards, ensuring a steady cool supply for healing brews. In modern rural restoration projects, enthusiasts revive ground spout techniques using sustainably sourced timber and food-grade sealants. Some eco-villages integrate wood pipelines alongside plastic systems, valuing the medieval approach for its low carbon footprint and use of local materials. Archaeologists also reconstruct these conduits to study hydraulic engineering, uncovering how simple tools and communal labor shaped water access long before industrial pumps. Today, adopting such low-impact solutions can inspire resilient water infrastructure, proof that sometimes the oldest methods remain the wisest. Fog nets and linen mist curtains. As fog drifts ashore, microscopic droplets collide with the fibers, coalescing into larger beads that trickle down into waiting troughs. Medieval fishermen and salt makers on the Atlantic fringe observed this phenomenon and adapted linen sheets, often salvaged from worn sails, as passive water harvesters. The process began with selecting the right fabric. Linen's natural hydrophilicity and tight weave made it ideal for capturing moisture without tearing in gusty winds. Villagers rigged frames, bamboo or hazel poles lashed together, upwind of dwellings. At dawn, they would walk along the nets with wooden paddles, dislodging accumulated droplets into carved wooden gutters. In less than an hour, a single 2x3 meter curtain could yield 10 to 15 liters of water, enough to top off cisterns or water small vegetable plots. Historical accounts from 14th century Galicia note that women gathered at fog lines each morning, turning the water collection into a communal ritual. Songs and prayers accompanied their work, intertwining practical labor with cultural belief in the Mist Mother, a spirit believed to bless the harvest with each dew-laden breeze. Though steeped in folklore, the underlying principle mirrored modern fog harvesting initiatives in Chile's Atacama Desert, where mesh collectors provide vital water to parched highland communities. Medieval fog nets were fragile and required frequent repair. Linen panels frayed at attachment points, and salty coastal air corroded wooden frames. Villagers developed simple maintenance techniques, brushing nets with seaweed ash to repel mildew and re-oiling poles with fish oil emulsion to deter rot. Such upkeep sustained the system through prolonged dry spells when springs ran low and rain was scarce. Today's sustainable architects draw inspiration from these medieval precursors. Fog harvesting meshes, made from high-density polyethylene, stand on coastal ridges worldwide. Yet the medieval model reminds us that local materials and communal effort can achieve similar results. Tree tapping for drinkable sap. Picture a grove of birch and maple, their trunks gleaming in dappled sunlight. Medieval villagers approached these silent giants with care, shaving a small patch of bark and inserting a wooden spile, a simple tube carved from elder or hazel. As the tree's sap flowed, they collected a steady drip of nearly clear liquid, sometimes sweet, sometimes slightly astringent, but always life-sustaining in times of drought. Tree tapping wasn't limited to temperate forests. Vines and acacias yielded drinkable fluids in more arid regions. Knowledge passed through oral tradition. Tap in early spring when sap rises. Avoid harming the cambium by using shallow cuts, and close the wound after harvest to prevent infection. Monastic herbalists recorded these practices in herbal codices, praising sap's mild antiseptic properties and its ability to staunch minor bleeding. Medieval households stored sap in ceramic jugs, sometimes fermenting it into low-alcohol beverages for longer preservation. In frontier settlements, a single grove could supply a family's drinking needs for weeks, reducing reliance on unreliable wells. Because tapping required minimal tools and left trees largely unharmed, it offered a renewable water source when aquifers ran dry. Modern survivalists and permaculturists revive tree tapping as an emergency measure. Workshops teach participants how to identify suitable species, drill pilot holes with hand tools, and fit reusable spiles. Sap yields vary. Birch may drip a liter per day per tree, so small orchards of tapped trees can sustain off-grid cabins during lean seasons. Archaeobotanical studies confirm tree tapping artifacts, spiles, and sap collection vessels in medieval farmsteads across Europe and Asia, underscoring the practice's widespread adoption. Today, combining tree tapping with rainwater and groundwater techniques creates a diversified water portfolio, just as villages once balanced springs, roofs, and living trees to survive the fiercest droughts. These 7 medieval water finding and harvesting techniques showcase how our ancestors turned simple materials and communal knowledge into life-saving systems. From the mystique of dowsing rods to the steady drip of tree sap, each method blends observation, innovation, and respect for the natural world. If today's builders, homesteaders, and emergency planners embrace these time-tested strategies, we can forge resilient water solutions that honor the past and secure our future. If you found these secrets as fascinating as we did, hit subscribe and ring the bell for more deep dives into forgotten survival skills. Share this video with anyone who might appreciate a medieval twist on modern preparedness, and let us know in the comments which technique you'd try first.